So here in section 2.7, exercise 2.7, this is number 77. Okay. So we need to find the two function f and g. Okay. So we need to find our function f. We need to find function g. Okay. This is what we need to find, such that h of x, we know, so we have a new function h of x, and this new function h of x is equals to f composite g of x, and which is same as f of g of x. Okay, so this is given to us, and we are given our h of x, which is f composite g of x, or which is f of g of x. This is given to us as 1 over 2x plus 5. We need to find f and g. Okay, so here we need to find function f, we need to find function g. We know the composite of f, we know the f composite g is given to us as 1 over 2x plus 5. Okay, now what would be the f function and a g function such that f composite g is equals to 1 over 2x plus 5? So we need to find the two functions, okay, f and g function, such that the composite f composite g is equals to 1 over 2x plus 5. Okay, now here, so our f, this is f composite g, and f composite g is same as f of g of x, right? So here, so when in the process of finding the composite, what is our first step? So we write down the definition, and once we write down the definition, what do we do when we find the composite function? We substitute for one function, right? So for example, so if you have f of x equals to x, 2x, and g of x equals to x cube. Okay, now how do we find f composite g? Let's see what is f composite g here. So the definition is f of g of x. Okay, the very first thing here we do is that we substitute for g of x. Okay, when we find the f composite g, we substitute our g of x at first, which is x cube here. So we have f as it is and x cube. Okay, then the next, in order to find f of x cube, what do? We substitute x cube for every x in our f function. So this gives us, we have 2, and for x we're gonna substitute x cube, so we have 2x cube. Okay, so this is how we find the composite. Now we are given a composite, we are given f composite g, and we need to find two different functions. Now what would be the, so here we need to substitute for g of x. So what would be the function for g of x that we're gonna substitute here? 2x. Okay, if you say your g of x is 2x, so you don't need this here. So let's try that. So if your g of x is 2x, so let's say, okay, it may not be correct, okay, it may be, so not sure. So let's say our g of x is 2 times x. Okay, then what should be f of x should be? So it would be 1 over 5, that's what you want. 1 over x plus 5. Okay, let's see if this works or not. Okay, so let's find f composite g. So f composite g is f of g of x. So you substitute g of x, so we have f, so for g of x we have 2x. Now in order to find f of 2x, you substitute 2x for x, so we have 1 over 2x plus 5. Okay, we get this composite, means yes, it can be this function. Or do we have any other f and g function whose composite is 1 over 2x plus 5?
Can also be 2x plus 5.
Yes, so you can also call, you can say your g of x is 2x plus 5. Okay, so g of x is 2x plus 5. and f of x has to be 1 over x. Okay, you are given a composite and you have to find the two functions. Okay, your answer can be anything here, but once you find the composite of those two functions, you must get 1 over 2x plus 5. Okay. Okay, this can be your one answer or this can be your second answer. Okay, so similarly, let's do the next one, 81. So in 81, our h of x, which is the f composite g from given, is cube root of 5x plus 7 minus 2. Okay, this minus 2 is outside the square root, minus 2. So this is h of x. So what would be f of x and what should be g of x? I'm sorry?
Is that 5x plus 4?
Oh, sorry, this is 5x plus 7. 5x plus 7 is square cube root of 5x plus 7 minus 2. Okay, what should be the function that you need to substitute here? What are you going to substitute here? 5x. Yeah, you can call your g of x the 5x. If your 5 of x is gx, what would be f of x? That's the cube root of x plus 7 minus 2, right? Or you can say this is your g of x, okay, and cube root of x minus 2 is your f of x. Okay, so here f of x, so g of x is 5x plus 7, or you can do 5x. So for this g of x, we're gonna write x for f function. So we have cube, so we have x for this expression for this g of x minus 2. Okay, you choose your g of x, and for that g of x, you're gonna write down x and you get the function f. Okay, this is from your homework. Does anyone have question? Okay, so let me do one more. That's gonna be number 95. Okay, so it's gonna be at number 95. In 95, we need to find the difference quotient. Okay, finding difference quotient means always we are finding f of x plus h minus f of x divided by h. This is what we need to find. Our f of x is given to us as 1 over x minus 3, and x is not equals to 3. Why so? Why x can be equals to 3 here? Yeah, right. When you choose your x to be 3, we have 1 over 0, which is undefined. 3 is not the domain. Okay, that's what it says here. Okay, now in order to find the difference quotient, we need to know what is f of x plus h at first. Let's find that. So how do we find f of x plus h? Our f of x is 1 over x minus 3. How do we find f of x plus h? Yes, you substitute whatever you have inside the parenthesis. We have x plus h for every x in your f function. Okay, so you substitute x plus h for every x. So we have 1 in the numerator as it is. So for this x, we're gonna substitute x plus h. So we have x plus h minus 3. Okay, so this is our f of x plus h. Now let's substitute in our difference quotient. Okay, so let me write one more time. So our difference quotient is f of x plus h minus f of x divided by h. Now let's substitute. So our f of x plus h is 1 over x plus h minus 3 minus f of x is 1 over x minus 3 divided by h. So you substitute your f of x plus h, and you have minus as it is, and you substitute your f of x, which is 1 over x minus 3. Any question up to here? Now let's simplify, okay? So if we simplify here, so in the numerator, so we have the two fractions. So this is one fraction and this is the other fraction. And we need to find the difference. And when we are adding or finding the difference of a fraction, we need to have a common denominator, right? So we need to have a common denominator. So let's find the common denominator. And if we see the denominator here, So we have x plus h minus 3 and we have x minus 3. So we can't factorize. These are the simplest factor, okay? So and these two are a different factor. And if this is the case, you just multiply these two and you get the common denominator, okay? So our common denominator would be, so common denominator would be x plus h minus 3 times the second denominator, which is x minus 3, okay? So you have the different denominator which is in the simplest form, then its common denominator would be always their product. Like for example, if you have 2 and 3 as a denominator, what would be the common denominator for 2 and 3? It's going to be 2 times 3 6, right? So if you have a 5 and 7, the common denominator would be 5 times 7, that's 35. Okay, and a similar thing goes here. These are the simplest form, okay, and these are the different from each other. So you multiply, you get the common denominator. Now let's make denominator of each fraction same as this common denominator. Now how can we make this denominator x plus h minus 3 equals to this common denominator? What do we need to do? So this expression has x plus h minus 3. Okay, we are trying to make x plus h minus 3 equals to x plus h minus 3 times x minus 3. So what do we have to do? So what factor is missing? X minus 3 is missing, right? So we use that missing factor to multiply numerator and denominator of this first expression. So you multiply in the numerator and denominator by x minus 3. Okay. Now let's do the similar thing for the second expression. So we have 1 over x minus 3. We are trying to make x minus 3. We are trying to make x minus 3 equals to this common denominator. The missing factor is x plus h minus 3. So we multiply the numerator and denominator of second expression by x plus h minus 3 in the numerator and in the denominator. Make sure you multiply both sides. Okay. Now here, okay, this is the one option, or the second option can be you can multiply numerator and denominator by the common denominator. That would be the other option. Okay, like you can use this common denominator to multiply numerator as well as denominator. That's the other option. Okay, now let's simplify here. Let's see what we have here. So we have x minus 3 times 1, that is x minus 3, divided by x minus 3 times x plus h minus 3. We have more than one term, so we need a parenthesis here. So we have this negative 1 time x plus h minus 3, that is x plus h minus 3, and in the denominator we have x minus 3 inside the parenthesis times x plus h minus 3 divided by h. Okay, let me know if you have any question here. So what we did, we find the common denominator and we make the denominator of each expression same as common denominator. Okay, so this is our common denominator and that's what we have for each of this expression. And if we have the common denominator, now we can simplify our numerator. So this is, let's write our numerator together. We have x minus 3. We have negative, and when you have the negative, you have to be extra careful, okay? You're gonna switch the sign of each term, or you're gonna put the parenthesis. So let's have parenthesis here, x plus h minus 3 divided by x minus 3 times x plus h minus 3 divided by h. Good. We have the common denominator, so we put our numerator together, and when you have the negative, make sure to have the parenthesis if it's more than one term. Okay, now let's simplify here. So we have x minus 3 as it is, negative times x, negative times positive h, negative times negative 3, that is positive 3, divided by x minus 3 times x plus h minus 3 divided by h. Okay, we distribute negative sign. Now here, positive x, negative x, that is 0, negative 3, positive 3, that is 0. Okay, so we are left with negative h divided by x minus 3 times x plus h minus 3 divided by h. Okay, so here this is our numerator. Okay, this expression is the numerator, and this is our denominator. So we have a fraction in the numerator. Okay, and if we have a fraction in the numerator or a denominator, these are the complex fraction. Okay, and we have to simplify this. In order to simplify, we write down our numerator as it is. So this is the numerator. So we write down as it is, negative h over x minus 3 times x plus h minus 3. Then multiply by the reciprocal of the denominator. So this is the denominator, okay, and this is the numerator. So reciprocal of h. What is the reciprocal of h? No. You are flipping the numerator and denominator. So that this h has a denominator 1, right? And if you flip, we get 1 over h. So we have 1 over h. Okay, so here we have a product. We have only one factor here. We have only one factor here. We can cancel this. H and h is cancelled. And the remaining is our final answer. So we have negative times 1, negative 1 divided by x minus 3 times x plus h minus 3. This is the difference quotient. Okay, it's a lot, but it's good to practice, and you won't have this like fraction on your test. Okay, you will have like a simple function, but you might get a square. Okay, but not the fraction. Okay, does anyone have question here? Okay, if this is the case, now let's go to the very last section before our exam third, and that's gonna be a section 2.5. Okay, so okay, let me go to the section 2.5. Okay, this is, I know you may not like the word problems, but these are the interesting section. Okay, now we did talk about the function. Now we'll try to use that function in our real life problems. Okay, so here, okay, so we have this. Okay, this is section 2.4. Okay, so we have this section 2.5, and I have a additional handout for section 2.5, and let me know who does not have this additional handout. Okay, anyone else? Okay. Okay, so we have the linear function, models, regression, variation. Okay, we're gonna have so many different topics here. Now let's start with the linear models. Now we did talk about our function. Okay, especially we focused on the linear function. Now here we will try to find. Okay, we'll try to express our real life problem as a function. Okay, in a function form. And we'll try to predict, or we'll try to estimate. Okay, so we can also make a decision from the function. Now here, so in section 2.5, okay, the very first thing is the linear model. And before this, let's talk about the linear function. So what kind of function is a linear function? Can you just give me an example of a linear function? When we graph, we get a straight line. That's right. Okay. Now, do we have a general form for the linear function? What it looks like in general, not specific, like very general. Can you just give me the general form of a linear function? X plus b. Okay. Or we all have seen the slope-intercept form, right? Y equals to mx plus b. That's a slope-intercept form. That is the linear, right? So if our function, okay, so if our any function f of x is equals to m times x plus b form, then our function is linear function. Okay, so which is same as the slope-intercept form. So this is a linear function. So we have a function f of x equals to mx plus b. Okay, m and b, these are the constant. Okay, m, b can be any number. M, b are real numbers. So we have a function f of x, or we can have a g of x, h of x. Okay, we have a function, and if that function is m of x, a number, some number times the domain plus a constant is the linear function. Okay, so here the x, the domain has the exponent 1. Okay, that's the very key thing. So here this x, its exponent is 1. Okay, if the exponent of your domain is 1, then that is the linear function. And in the next topic we will talk about the quadratic function, and in the quadratic function the exponent would be the 2. Okay, like if we have a function of this type, f of x equals to ax squared plus bx plus c, so this is our quadratic function. And if we compare these two, so here we have the input with our exponent 2 as the degree. Okay, and in our linear function the degree is always 1. Okay, and in this section we will use this linear function as a model, okay, as a mathematical model. Okay, and with the help of this linear function we will make a prediction, or we will make an estimation or decision. Okay, now let's go to an example, then it will be more clear. So here we have an example. At the end of each year, okay, so we have Jocelyn's employer gives her an annual bonus of $1,000 plus, okay, so she gets a bonus of $1,000 plus $200 for each year she has been employed by the company. So something very key things here. So she gets the bonus. Okay, so at the end of each year she gets the bonus, and the bonus is $1,000 plus $200 for each year she has been employed by the company. Okay, so if this is the case, what would be the bonus that she received on her very first year? So if she worked for like a 1 year, okay, how much bonus she will receive? 1,200. Do you all agree? Because she receives $1,000, okay, plus, so it doesn't, plus $200 for each year. So it's going to be like a $1,200 bonus that she's going to receive. Okay, now the very first thing that we have to do here is that we have to find a linear function that relates the bonus to the number of years of our employment with the company. We need to write a linear function. And when we write a linear function, what do we need? So in a function, what do we find? So if you have a function, what the function has? What are the parts of a function? The function must have a slope, is input, right, which is the domain, right, or the output, right? So we need to have an input, we need to have an output. Now in this case, what would be the input? So what we gonna use as an input? I'm sorry? 200. So input is a variable. Okay, so what variable do you want to use as a domain? Okay, is your bonus input or output? So one more time. So here, so let's go back to the problem here. So she gets the bonus. Okay, so she gets the bonus. Okay, and the bonus is $1,000 plus $200 for each year that she has employed by the company. So if this is the case, so what? Okay, so if this is the case, what you gonna input? Like for example, if you wanna find the bonus after 5 years, how much bonus will she get after 5 years? Like if she worked for 5 years, how much bonus will she get?
2,000.
How did you find that?
Input the 5 years.
So you have 1,000 fixed, right? Then plus she get 200 for each year. Then you do 200 times 5, right? So you get 200 times 5, that's 1,000 plus 1,000. So you get the 2,000. So what changes here? The year, right? So we input our year. So T gonna be our domain. So here T is a domain. So let's call, since we have a time, so let's be more specific. So we have T, or you can use ABC, doesn't matter. If you define your X as a number of year that she has employed, that's okay. Okay. So our T is the input, okay? So this is what you're going to input in order to find the bonus, okay? And this T is the number of years employed, okay? This is the number of years employed. Okay, what about the bonus? What are we trying to find with this T?
B for the bonus.
So we are finding the bonus, right? And you can call anything. So it's a bonus, so let's call B. So B is the bonus and this is our output. This is the output.
Should it be B of T?
Okay, yes, or we're gonna do that, okay? So here, we'll come to that. So here B represents the output, okay? Or it is the bonus. Okay, now here, so we have these two different variables, T and bonus. Which one is dependent? Now, does the bonus depend on time? So as the time changes, bonus changes, right? So bonus is the dependent variable, okay, and our T is the independent variable. And so our domain is the independent and our output is always dependent, okay? Our output depends on what input we have, okay? So let's find the bonus for the T time years, okay? So bonus, so our bonus is, so she get $1,000 plus $200 for each year. And what did we use for each year? We have a T in general, so we have 200 times T. So this expression depends on T, so it means B is a function of T. So we have B of T as a function, and this is equals to 1000 plus 200 T. Okay, so here the bonus, B is the bonus, it depends on T. It means bonus is a function of time. Okay, as the time changes, our bonus changes. Okay, and is this a linear function or not? So our variable is, our domain is T, and the exponent of T is 1 here. So it means this is a linear function, and this is the linear model for this one. Okay, so that is for our part A. So this is for part A. So we are asked to find linear function. So we are asked to find the linear function that relates the bonus to the number of years of our employment with the company. So we have this bonus here, and this bonus depends on the time. Okay, good. Now let's go to the number B. Okay, now we need to use this function, okay, to calculate the annual bonus she will receive after she has worked for the company for 8 years. Now she worked for 8 years and we want to know how much she will get as a bonus. Okay, so what is that 8 for us? T, right? Okay, that's good. So our T is 8, and what do we want to find? We want to find the bonus when time is 8 years. Okay, so let's find B of 8. So B is a function here. And how do we find this B of 8? You substitute 8 for every T on your bonus function. So we have 1000 as it is plus 200 times 8. So this is 200 times 8 is 1600 plus 1000, that is $2600. Okay, so she will receive $2600 bonus once she employed for 8 years. Okay, let's go to the number C. Okay, we need to calculate how long she would have to work at the company for her annual bonus to amount to $3200. So we want to know how long she need to work to get $3200 bonus. Now what are we asked here? So if in part C, so are we asked to find the input or output? It tells you calculate how long Jocelyn would have worked at the company so that her bonus would be $3200. So what is asked to us? Are we finding the bonus or time? Time, right? And what is given to us? What is that 3200? Bonus, right? So let's take our bonus function. So our bonus function b of t is 1000 plus 200t. Okay, we are asked to find t. We don't know what is t, but we know the bonus, and that bonus is 3200. So we have 3200 equals to 1000 plus 200t. Now we solve this equation. This is a linear equation, and we know how to solve this equation. You subtract 1000 on both sides. So 3200 minus 1000, that is 2200 equals to 200t. Now we need to get rid of 200. For that we divide both sides by 200, and our t is equals to 11. So she need to work 11 years to get $3200 bonus. Okay, does anyone have question here? Now let's go to our last part for this problem. So interpret this slope and y-intercept for this problem both verbally and graphically. Okay, now our function, so for number D, let me write bonus function. Our bonus function is 1000 plus 200t. Can I write this as a 200t plus 1000? Is it okay? Is it still same thing, right? Now for this function, okay, what is the slope? How do we find the slope if we have a linear function? So what give us the slope here? Yes, the coefficient of your t is the slope. Okay, so here this is the slope, and what about this? This is our y-intercept. Okay, if we compare our function with our general function, so we have mx plus b. Okay, if you compare, your m 200 is the slope and b 1000 is the y-intercept. So here slope m is 200 and b, which is y-intercept, is $1000. Now what does this mean? What does the slope 200 mean for us here? What does that tells us? Okay, number of years. So 200 years, that's what we are talking about. So the bonus per year, right? It means, okay. So what about $1000 then? What is $1000? That's the bonus, but what kind of bonus?
She's getting that no matter what, no matter how many years she's been added on.
It means that's the bonus when, is that the bonus when t equals to 0, right? T equals to 0 means what is in the real life? What is that t equals to 0? Like once she start working, she's getting $1000 bonus, right? So this y-intercept is our y-intercept means is when our t is equals to 0, and t equals to 0 means when she start working, she's getting $1000 bonus. Yes.
That is, since it's an annual bonus,
Uh-huh.
does that mean that she has to work a year to get that 1000?
Okay, now here, okay, that's a good question.
Like in other words,
So her annual bonus is $1000 plus 200.
like T has to be 1 or greater,
Okay, but now from this function, so when t is equals to 0 means it's the starting time, right? So t equals to 0 means like the day is start. And if this is the function, this is the function that help us to find the bonus, okay? And from this function, what we can say that if c is starting, then it means t is 0, so c have to get $1000 as a starting bonus. Okay, but annual is she get the 1000 plus 200. Like once she have worked for 1 year, she gets the 1000 and plus $200. here just we are trying to interpret, okay, but it may not be applied in her company. But if we are talking about the y-intercept here, so our y-intercept is $1,000, right? And it means when she starts, she gonna get the bonus, starting bonus as a $1,000. Okay, we are only interpreting, but it may not be real. But there might be some company giving us a starting bonus too, right? So it depends. And what about $200? So what is that $200 here? That's the slope, but what does that mean here? So okay, now let's define what is slope. How did we define our slope? Slope is equals to change in rise over fall, right? Oh, rise over run, bless you. So we have rise over run. This is our slope. Or we can also write change in, rise means change in y-axis over change in x. Change in x. Now in our case, what is y? In this specific example, y is the output, right? So what is y here? Y is bonus, right? So change in bonus. So this 200 is change in bonus over x is, what is x? X is time, right? Okay, x is time. And our slope is 200, that's what we know. And the denominator, if it's nothing, is 1. So it means when the time changes by 1 year, what is the change in bonus? That's the $200. Okay, or you can also tell that like as the time changes by 1 year, her bonus increases by $200. That can also be the way to interpret. Okay, now let's graph this information. Okay, we also need a graph, and it's easy. We have a slope, we have a y-intercept, so it's gonna be easy to graph here. So we're gonna graph. So what do we call our horizontal axis in this case? What will be our horizontal axis? Horizontal axis is the domain, right? And our domain is time. So t is the horizontal axis, bless you. So what would be our y-axis? Y-axis is the output. So what is bonus? B of x, B of t. B of t is the bonus. Now, can we have this side of t here? Does this even exist? No, right? So it means we can't have a negative. So we can have a 0 time. That's a starting, like a 1 year, 2 year, right? 3 year. Okay, so what is the y-intercept? $1,000, right? So let's say this is 500 and this is 1,000. So our y-intercept is 1,000. So this is the 1 point. Now, how can we use slope here to find the second point? So this is 1,500 and this is 2,000. How can we use slope to find the second point? So our slope is 200. It means as you move 1 year right, your bonus changes by 200 or bonus increases by 200, or you run 1 unit on the right and you go up by 200. Okay, so we are here. So let's go right by 1 year, okay, and up by how many? 200. So this is, okay, let's say this is 1200. So up by 200. So this is our second point. And we connect these points, we get a graph. Okay. Can we extend this graph on the left or not? No, right? Because this negative time doesn't exist. So it's starting from here and all the way you can go. And you can just use this function to predict the bonus. Okay. So this is one of the linear model, okay, that we can use in our real life problems. So linear function, it helps us to find the bonus. And we can also predict, okay, like if she has worked for 20 years and if she want to find her bonus after working for 50 years, she can use this function, right? So if she gonna work for 50 years, what would be her bonus? Let's find out that. So our T would be 50. So we have 1000 plus 200 times 50. 200 times 50 is 10,000 plus 1000, 11,000, right? So that's gonna be the bonus. So that would be the estimate that she can make with the help of this function. Okay. All right. So if any company offers you a bonus of this model, do you agree to work on that company? How many of you will agree to work? So your company is that says that they're gonna offer with this your bonus changes with this model. Are you gonna work? Is it good enough or is not enough?
So it's just a bonus, so
It's the bonus, okay? It's not your salary, okay? It's not your salary. It's the extra money that you get like at the end. And even like from here, we can say at the starting, they're gonna give the 1000. So starting they are getting 1000, and every year it increases by 200. And after 50 years, you're gonna, after working for 50 years, it would be like 11,000 bonus. On the 50th year, that would be the 11,000, okay? All right. So this is a good option. Okay, does anyone have question here? Okay, before I start next, so I want you to add this example. I forgot to print this page. Okay, let's do this one, then we'll be back, okay? I forgot to print this page. And once we do this example, we'll be back to the previous one. So here we need to find the linear function, okay, whose input and output are given in this table. So input is given, output is given. So when your input is 1.3, your output is 4.5. When your input is 2.6, your output is 1.9. We need to find the linear function, okay? Now how do we find the linear function? In order to find the linear function, we need to know the slope. Yes.
doesn't have it.
Yes, not only yours, all of yours don't have this problem, okay? I forgot to print this one. So you need to write. So just write down this table and copy that problem. Okay, now in order to find the linear function, we need to find the slope, okay? So we have input x, which is 1.3, and when input is 1.3, our output is 4.5. Input and output combined give us a point, right, on a graph. So this is 1 point. So our input is 2.6, and the output is 1.9. So this is the other point. Now let's find the slope. So let's call this is x1, this is y1, this is x2, this is y2, and the slope m is equals to, what is slope? y2 minus y1 divided by x2 minus x1. So this is the, now let's substitute. Our y2 is 1.9 minus y1 is 4.5 divided by x2 is 2.6 minus x1 is 1.3. So we have negative 2.6 over 1.3, and this is negative 2. So this is the slope. Now how can we find the intercept? Is it possible to find the y-intercept from this information?
Yes.
How do we find? Okay, that's right. So we're gonna use the point slope form. Okay, we use point slope form to find the linear equation. That's what we did. So let's use our point slope form, and point slope form is y minus y1 equals to m times x minus x1. This is the point slope form. So here, do not substitute anything for y and x. Okay, so you're gonna substitute for x1, y1, and m. So we have y as it is. Y1 is 4.5 equals m is negative 2. We have x minus x1 is 1.3. So let's simplify on the right side. Negative 2 times x, negative 2x, negative 2 times negative 1.3, positive 2.6. So we have y minus 4.5 Now let's write this in a slope intercept form. Okay, we are writing in the slope intercept form. So we're gonna solve for y. So let's get rid of 4.5. So we're gonna add 4.5 on a both side, and our y is equals to negative 2x plus 2.6 plus 4.5. What is this equals to? 7.1. Okay, 7.1. Okay, and we also can write y as a f of x, right? It's the same thing. Y is also our output, so we can replace our y by f of x equals to negative 2x plus 7.1. So this is the linear function, okay, for this table. F of x equals to negative 2x plus 7.1. So we have 7.1 here. So you find the slope, use the point slope form, because we are not given y-intercept, so we're going to use point slope form. You solve for y, and y is the output, is the f of x, okay, and that give us the linear function. Okay, any question here? Okay, so let's do this much for today. Okay, remaining we'll do tomorrow. And if you have any question, let me know. I'll be here.